Okay, so with this equation here, we need to do a little bit of work first to sort of make this look a bit easier for us. So we're going to expand this bracket here. So we've got 3 cosec theta times cosec theta. So that'll be 3 cosec squared theta. And then 3 cosec theta times minus 1. So that's minus 3 cosec theta. Okay, just by expanding that bracket. And that's it. You can't simplify it any further. But then you realise that you can't change the cosec theta. Okay, so you need to get everything in terms of cosec theta. Okay, because you can't change this. You can change this, but you can't change this. So we'll keep that as it is. We'll keep that as it is. We'll change that then in terms of cosec theta. So remember our result: sine squared plus cos squared is equal to 1. So to get cosec squared theta, I need to divide by sine squared theta, because sine squared over sine squared is 1. Cos squared over sine squared is cot squared. And of course 1 over sine squared is cosec squared theta. So I'm going to replace the cot squared theta. So what I need to do here is take that 1 over. So I get cot squared is cosec squared theta minus 1. So sub the expression for cot squared theta in here. So I'll have 3 cosec squared theta minus 3 cosec theta equals to 5 bracket cosec squared theta minus 1 and then minus 9. So again, then I got a bracket here because I got to times through by 5. So 5 cosec squared theta minus 5 minus 9. What I do then is I take everything over to the right hand side. So I'll have 0 equals. If you think about it, I got 5 cosec squared theta. If I take that over, it's going to be minus 3 cosec squared theta. So I'll have 2 cosec squared theta. Take the minus 3 cosec theta over, so that'll be plus 3 cosec theta. And then minus 14. So now we can factorize this then. 2 brackets. So using our method for factorizing, we can put 2 cosec theta in both brackets. Over here then, we got to do 2 times minus 14, so that's minus 28. So we need to think of 2 numbers that multiply to give minus 28, but add up to give 3. So this will be positive 7, negative 4, yeah? Because those 2 will times to give minus 28 and add up to give positive 3. So remember then it's equal to 0. And don't forget then, using this method, we've got to divide by 2. So we get 0 equals to 2 cosec theta plus 7. And then the second bracket just becomes cosec theta minus 2. So then either 2 cosec theta plus 7 equals 0 or cosec theta minus 2 equals 0. So that means we've got cosec theta equals to minus 7 over 2 or cosec theta equals to 2. Now remember, cosec theta is just 1 over sine. So 1 over sine theta is minus 7 over 2. And the same here, 1 over sine theta is equal to 2. So that means then, if we flip this, we get sine theta equals to minus 2 sevenths. So we flip that. Or sine theta equals 2. We flip that, we'll flip 2. And remember, 2 is the same as 2 over 1. So it becomes a half. So then we get 2 results then for theta. So I know that's 30 degrees. Let's see what this one is. Sine to the minus 1 of minus 2 sevenths. And we get minus 16.6 degrees. Okay, so we're going to draw a sine graph. So we need to go to minus 90. So maybe every 3 centimeters to represent 90. So minus 90, 0, 90, 180, 270, 360. So upper limit of 1, lower limit of minus 1. So definitely do. Okay, well, so we've got, what have we got, our results here? So we've got minus 16.6, which is about there. And that just enables us then to see the other results. Now, minus 16.6 is no good for us because it's outside the range, but we can get the other results then. So we see by symmetry, that'll be this way from 180, so 180 plus 16.6, and then this way back from 360. So we get 196.6, 196.6, and 343.4. The other result then, where is equal to a half. So we got 30 degrees. Okay, 30 degrees, and of course you can see that one's going to be 150, yeah? Because 180 minus 30. So we get 30 degrees and 150 degrees. So altogether then we could say 30 degrees, 150 degrees, 196.6 degrees, and 343.4 degrees.